Hello, this is Math Jazz from Almost Cool. This series of videos is a trigonometry review. I divided the review into several topics and gave each of them its own video so that these videos could be shorter and to the point and easier to follow. Our first video, which is this video, is on the definitions of trigonometric functions. But before we talk about the definitions of trigonometric functions, we're going to have to talk about angle measure. Since trigonometric functions are functions that take in an angle and spit out a ratio, if we don't have a way of measuring angles, then we can't really talk about trig functions. The two primary ways that calculus students will measure angles are with degrees and with radians. The ancient mathematicians, when they were trying to conceive of how do we measure angles or how do we figure out how big an angle is, they decided that they would look at angles as being sections of circles, and they decided that a circle should be 360 degrees around. The reason they chose 360 rather than what might seem nicer to us as modern mathematicians, maybe 100 or 1,000, is because back in the day, division, particularly division that left remainders or had fractions or decimals of some kind, was really hard. And so, since they basically could pick any number they wanted to represent the total number of degrees around a circle, they picked a number that would divide easily without remainders or fractions. And so they picked 360 because it's able to be divided by 2, 3, 4, 5, and 6. Whereas 100 isn't divisible by many of these numbers, and 1,000 isn't divisible by many of these numbers. Now, another way of measuring angles is with radians. We can talk about an angle as being, if we look at an arc, what percentage of that of a circle contains that arc. And since the ratio between the distance around a circle is with the radius of that circle is constant, the ratio being 2 pi, we can talk about how far around a circle we're going by talking about how much of the radius of the circle we're going around. Are we going 1 times the radius around? Are we going 4 times the radius around? The whole way around a circle is going to be 2 pi times the radius around. So that means that half of the way around is going to be pi times the radius around, and a quarter of the way around is going to be half of pi times the radius around. So the units we're going to be using are the radius itself, and that's where the word radian comes from. So we can either talk about an angle being a 180-degree angle, or we can talk about it being pi radians of an angle. So to convert between the two units, we use the relationship that once around the circle in degrees is 360, and once around the circle in radians is 2 pi. So this equation gives us the ability to convert between degrees and radians. However, most calculus students will primarily use radians. If you do not see any sort of other clues or hints in a problem that you're trying to do, assume that the problem was written for radians rather than degrees. Only assume that a problem is written in degrees if it specifically tells you that this problem is using degrees and not radians. Just like there are two ways that we were talking about of how to measure angles, there are several ways of defining trig functions. We're going to use a hybrid method where we're going to define sine and cosine using the unit circle like the ancients did, and then we're going to define the other trig functions as quotients involving sine and cosine. Remember, division was hard to ancient mathematicians, so this is not how ancient mathematicians would have thought of, say, tangent, cotangent, and other trig functions. But this is how we can think about it, because for us, we have decimals and we have fractions, and to be honest, we also have calculators. So division is not so scary a thing as it once was. Also, we're going to have to talk about the unit circle, and we're going to have to talk about quadrants of a plane. So this is a unit circle. It is a circle of radius 1 centered at the origin, and also we're dividing the plane into 4 rectangular pieces that meet at the origin, and we're going to number them 1, 2, 3, and 4, going counterclockwise, just as in the diagram. Now, sine and cosine, we are going to define these as being the x and y coordinates of the point an angle of theta away from the x-axis when traveling along the unit circle counterclockwise. Here's a diagram that shows that. So if we were to start at the point 1, 0 and travel around the circle counterclockwise an angle of theta, we would hit a point here. And I've drawn a ray that goes from the origin through that point. That point has an x and a y coordinate. We're going to call the x coordinate cosine and the y coordinate sine of theta. Now, this might seem different from how you defined these ratios in a trigonometry class or an earlier calculus class, but this comes out to be equivalent to the alternate trig definition, which is sine as being the length of the opposite side of the triangle divided by the hypotenuse, and cosine as being the length of the adjacent side of the triangle divided by the hypotenuse. Since, in this case, the hypotenuse is the radius of a unit circle, and that distance is 1. So the y coordinate of this point is the length of the opposite side, and the hypotenuse is 1, so the opposite side divided by 1 is just itself, but that's also the sine. So we can see that these two definitions agree with each other, even though we came at them from different angles. Now, we're going to define the other 4 trig functions as being fractions that involve sine and cosine. So tangent of x is equal to sine of x over cosine of x. Cotangent of x is equal to cosine of x over sine of x. Secant of x is equal to 1 over cosine of x, and cosecant of x is equal to 1 over sine of x. This, again, is not how the ancients defined it, but this is how we're going to define it for our intents and purposes. And from here on out, we're going to talk about how the ancient mathematicians defined trig functions. This is probably not going to show up on any calculus class. It's definitely not going to show up on a calculus test. But anciently, these ratios were defined as lengths of line segments on the diagram of a unit circle, much in the same way that we defined the sine and cosine on a unit circle. Here's a diagram that shows that. I'm going to color these lines so that we can see what line segments we're actually talking about here. And again, this probably won't show up on any calculus test for any calculus class, but it's interesting nonetheless. These 2 red line segments represent tangent of theta and cotangent of theta. They're defined as, let's start with tangent. Tangent is the distance along the vertical line x equals 1, starting at the x-axis and ending on the ray that makes an angle of theta with the x-axis. Cotangent is defined as the length from the y-axis along the line y equals 1 until we hit that same ray that we defined in tangent. This length is the secant. It is the length along the ray until we hit the line x equals 1. And cosecant is similar. It is the distance along this ray from the origin to the point where the ray hits the line y equals 1. Now, there are some very pretty pictures on, or actually animated images on the Wikipedia page on trigonometric functions, and I encourage you to go see them. They're kind of mesmerizing. You can stare at them for a while as you see this ray spin around the unit circle, and you see the cosine and cotangent get traced out on these kinds of diagrams. It's very pretty, and you should see it. But anyway, um, modern mathematicians don't define uh, these functions in this way either. That is, these ratio ways either, or they don't define it in the unit circle ways. Modern mathematicians use power series to define these functions. Now, power series is a little beyond the scope of this trig review video. However, if you're taking a calculus class in college, power series is typically taught in the first year towards the end of the year. So somewhere around the end of your second semester of calculus. If you're in high school and you're taking advanced placement calculus, uh, power series shows up in the BC exam, but not in the AB exam. So that's something for you to look forward to if you're interested in how modern mathematicians will think of these trig functions. In addition to this, we didn't talk about this, but there are more than 6 trig functions. Um, Other trig functions that exist are like Haversine, cohaversine, versine. They're also defined as different lengths of lines on unit circle graphs. And again, they're artifacts from when division was a very hard process to do because of the limitations of Roman numerals. But if you're interested in learning more about the history of trig functions, the Wikipedia page actually has some very good information on let's call them antiquated trig functions or obsolete trig functions. Thank you for watching this video. My email is given there, mathjazz9@gmail.com. Feel free to send me emails suggesting future topics for videos, or if you found any errors in my videos, or anything else. And have a great day. Bye.